Hi, this is Math 1650, and in this video we'll be looking at determining a sample size when you're estimating the mean formula. And then after that we'll look at just some more examples with confidence interval for practice. Alright, so our margin of error was the z alpha over 2 times the population standard deviation over square root of n. Right, to solve this for n, we'll multiply the square root of n to the one side, get it by itself, and divide by the margin of error. And then that's the square root of n, not n, so we have to take the square of both sides. And that is why everything here is squared. But it's just the z alpha over 2 times standard deviation over the margin of error. And then all of that is squared, and you get your estimating mean for a sample size. Okay. The IQ test is designed so that the mean is 100 and the standard deviation is 15. Find the sample size necessary to estimate the mean IQ of statistics students. We want to be 95% confident that our sample mean is within an IQ score of 2 points from the true mean. The mean for this population is clearly greater than 100. The standard deviation for the population is probably less than 15. Because it is a group with less variation than a group randomly selected from the general population, if we use 15 as the population standard deviation, we are being kind of conservative and getting a wider interval or a greater sample size. So by being conservative, that will make our sample size at least as large as necessary. Determine the required sample size. Right, so 95% means we have to look at this from a 0.975 area from the left to get our z alpha over 2. Okay, so that's the first thing. So go into analysis, normal distribution, and 0.0975. I know we've probably done this one a couple of times. I think I just did that one. The same thing I did last time. 1.96. Okay. So now we want to find the sample size. So we do 1.96 times the standard deviation, which we said is 15, over the margin of error, which we said is 2. And then this whole thing is going to be squared. And we get 216.09. So we'll round this up to 217. You have to make sure we round up so we have enough. Right, now on StatDisk, we want to do the sample size determination. Go to analysis, sample size determination, estimate mean. Okay, we do the margin of error. I'm sorry, the confidence level 95%. Margin of error is 2. Population standard deviation is 15. And we won't know the population size, so we won't need it. We'll evaluate, and we get 217. There's a chance this number may be a little bit different if we round too much with our 95% z-score. But in this case, we didn't. The 1.96 was fine, and it resulted in the same number. And one thing I want you to notice is if we don't put in a standard deviation, because we have a sample, it's not going to do anything. So we have to have the population standard deviation. Alright. So let's say a medical researcher wants to estimate the average cholesterol level of patients in a certain age from previous studies. The population standard deviation, and this group is known to be 30 milligrams per DL. The researcher desires a margin of error of no more than, switch back to this, than 5 milligrams per DL. And we want a confidence level of 0.95. Right, so again, we want to find our n, and we're going to use just this for this. So 0.95, margin of error is 5, and population standard deviation is 30. We evaluate and we get 139. Okay. And if we used the formula, n equals 1.96, because it's still the same confidence level, times 30 over 5, and then everything squared. We get 138.3, which rounds up to 139. Okay, we always round up. Alright, so now we're going to get into more problems. Some will involve confidence level, some will involve sample size problems. If you want to, you can pause the video, go through, try these problems, see if you can figure things out, and then come back and look and see what you got, what you may have missed, or what you can't figure out, and so on. Okay, so people have died in boat and aircraft accidents because an obsolete estimate of the mean weight of men was used. In recent decades, the mean weight of men has increased considerably, so we need to update our estimate of that mean so that boats, aircrafts, elevators, and other such devices do not become dangerously overloaded. Using the weights of men from a random sample, we obtain these sample statistics for the simple random sample. N equals 40, and the average weight is 172.55 pounds. Research from other sources suggests that the population of weights of men has a standard deviation given by 26 pounds. Okay, first, find the best point estimate of the mean weight of the population of all men. Okay, this is usually not something you have to calculate. Best point estimate. If it is something you calculate, it'll be based on your data. But this is given. X bar equals 172.55. Just sample mean. Construct a 95% confidence interval estimate of the mean weight of all men. Alright, so we have to put in what we need. So here n equals 40. Sample mean is 172.55. Population standard deviation is 26. Confidence level is 0.095. Right. So for this, we are going to go analysis, confidence interval. We are dealing with a mean, so mean one sample. We don't have the data, so we'll use summary statistics. 0.95 is your confidence level. 40 is your sample size. Mean is 172.55. Sample standard deviation, we don't have. Population standard deviation is 26. We evaluate. We have margin of error of 8.06 and a confidence interval of 164.493, less than the mean, less than 180.607. Right. So our true value is somewhere between 164.5 and What do the results suggest about the mean weight of 166.3 that was used to determine the safe passenger capacity of water vessels in 1960? This value falls in the interval and could still be the true average, but it's lower in the interval, and it's likely the true value has increased. It is especially since the 172.55 was higher than the 166.3. So there is slight evidence that the average weight has now increased. Maybe not by much. So assume that we want to estimate the mean IQ score for a population of statistics students. How many statistics students must be randomly selected for IQ tests if we want to test? We want 95% confidence level, and the sample mean is within 3 IQ points of the population mean. So confidence level, we're looking at 0.95. Margin of error, looking at 3. From previous problems we've done, the population standard deviation is 15. Population standard deviation equals 15. Alright, so let's put this in. So we gotta go to sample size determination, estimate, let's see, we'll target around mean. So estimate mean, 95% confidence level, margin error of 3, population standard deviation 15, we get 97. Alright, do a couple more problems. A common claim is that garlic lowers cholesterol levels. In a test of the effectiveness of garlic, 49 subjects were treated with doses of raw garlic, and their cholesterol levels were measured before and after the treatment. The changes in their levels of cholesterol have a mean of 0.4 and standard deviation of 21. Use the sample statistics with n equaling 49, the mean equaling 0.4, and the standard deviation equaling 21 to construct a 95% confidence interval for estimate of the mean. Right, so we know n equals 49, x bar equals 0.4, standard deviation equals 21, and confidence level is 0.95. We're looking for the margin of error and then the confidence interval. So confidence interval, and we are dealing with the mean, so mean one sample. We don't have the data, so we'll just use the summary statistics. Confidence level is 0.95, sample size is 49, sample mean is 21. Oh, no, sample mean is 0.4, standard deviation is 21. Don't have the population standard deviation. We evaluate. We get margin of error of 6.03 and confidence interval of 5.63. less than the mean, less than 6.43. Alright, so what does this mean? Well, one thing to notice is 0. A change of 0 is shown here. So it's likely there isn't any change at all. Alright, so let's do another one. We want to find mean length of men's forearms from elbow to fingertip with a 99% confidence level. Measure 32 men arms. Sample mean is 14.5. Sample standard deviation is 0.7. We'll look for the margin of error and the confidence interval. So 0.99 for in mean one sample. 32. Margin of error is 14.5. Standard deviation is 0.7. Don't have the population standard deviation. Body weight 0.33. 33. Just make it 34. 0.34. And confidence interval is 14.16 to a mean of 14.84. All right. One more on this page. In a sample of 40 cocoa chocolate chip cookies, the mean number of chocolate chips was 22.7. Standard deviation is 3.2. And this is for a sample of 40. And we want a confidence level of 95%. So margin of error, confidence interval is what we're trying to find. So 0.95, 40 cookies, 22.7 is the mean, and deviation is 3.2. Evaluate. The margin of error of 1.02. And a confidence interval of 21.68 to 23.72. So that's somewhere between those two numbers is what we expect the average to be. Alright, so got a few more to go. We're going to really start jumping around here in different types of problems, and we're going to go into a little bit of detail on these problems. Suppose in a study of 1,228 randomly selected medical malpractice lawsuits, 856 of them were later dropped or dismissed. What is the best point estimate of the proportion of medical malpractice lawsuits that are dropped or dismissed? So we're looking for a proportion. So here, the proportion for the sample is 856 over 1,228. Which let's get a proportion value for this. 856 divided by 1,228 is 0.697 or 69.7%. Right, that is our best point estimate. That's the most calculation you'll have to do with a proportion problem for the best point estimate. We want now a 99% confidence interval. So again, we're dealing with proportion. So number of successes is 856. Sample size is 1,228. Confidence level is 0.99. Now we're in mean one sample, we have to switch this. Confidence interval, proportion 1 sample, 0.99. Sample size is 1228. Number of successes is 856. And we get a confidence interval of 0, right up here, 0.663, less than p, less than 0.731. Does it appear that the majority of lawsuits are dropped or dismissed? How can you tell? Alright, so the answer to this is yes. The confidence interval is well above 0.5. So the majority, which would be above 0.5, is not contained in the the 0.5 is not contained in this, and actually it's nowhere near it. So yes, majority of these lawsuits are dropped or dismissed. Right. A newly hired manager of a company that provides cell phone service wants to determine the percentage of adults in his state who have lived in a household with cell phones and no landline phones. How many adults must he survey? Assume he wants to be 90% confident that the sample percentage is within 4 percentage points of the true population percentage. So margin of error is 0.04. Confidence level is 0.9. We are looking for the sample size. So we'll go analysis, sample size determinator, estimate proportion. And proportion is because we are looking at percentages here for what we're determining. Okay, so 90 is our sample confidence level, margin of error 0.04, and then evaluate, and n equals 423. Right now, assume that a recent survey suggests that about 8% of adults live in a household with cell phone and no landline phones. So estimate a p equals 0.08. We'll add that into this. And it reduces our needed sample size to 125. So why is this the case? Having more information and an expected proportion allows us to have a lower sample size that is needed. All right, let's go to another one. Here a simple random sample of 125 SAT scores has a mean of 1522. Assume that the SAT scores have a population standard deviation of 333. Construct confidence intervals. We're going to do it for 95% and 99%. So go to analysis, confidence intervals, mean one sample. Confidence interval, we'll start with 95%. We have an n of 125. We have a mean of 1522. Standard deviation, that's population standard deviation of 333. Evaluate. And we get confidence interval 1463.6 624, less than the mean, less than 15, oops, 1580.376. Right, now let's switch it to a 99%. And we get 1445.28, 0, less than the mean, less than 1598.720. Which confidence interval above is wider and why? Well, the wider confidence interval is clearly our 99%. The lower number is lower than our 95%, and the higher number is higher than our 99%. So the interval of close to 53, whereas the other one's interval of about 17. The y, the 99% is wider because we need a wider interval to be more confident. Considering the only way we can be 100% confident is if our interval is from infinity to negative infinity to infinity. Right, so we need a wider range to be more confident. Alright, let's do one on a keto weight loss program. In a test of a new keto weight loss program, 40 individuals participated in a randomized trial of overweight adults. After a year, the mean weight loss was 2.1 pounds, standard deviation of 4.8 pounds. What is the best point estimate of the mean weight loss of all overweight adults who follow the keto program? Well, it's our sample mean. Sample mean was 2.1 pounds. Okay. We want to construct a 99% confidence interval for the mean weight loss. So we're looking at the mean. So we have mean on sample. Confidence interval is 99%. 40 individuals is our sample size. Sample mean is 2.1. Sample standard deviation is 4.8. No population standard deviation. And we get a weight loss of 0.045 to 4.16. Right. Does the keto program appear to be effective and why? Okay, so we're going to look at this statistically. Statistically, this confidence interval is above 0. Not by much, but is above 0. So technically, the keto program appears to lead to some weight loss. Lead to some weight loss. Is this practical? No. The weight loss is very small and doesn't appear to be worth participating in the program. You fast for a day, you may lose 2.1 pounds. A lot of people want to jump and basically look at the practical side when answering the question about effectiveness. You know, we separate in statistics. Talking about effectiveness, we looked particularly at the data. Does it appear that it's doing something? Then we look at whether it's practical or not. Okay, one more problem. If the population standard deviation is 2.5, what sample size is needed to estimate the mean white blood cell count for the population of adults in the United States? Assume that the sample mean is within 0.2 of the population mean. And we are looking at a sample size determination. We want to check different confidence levels. We want to go analysis, sample size determination, and we're looking at the mean, so estimate mean. Margin of error is 0.2. Population standard deviation is 2.5. And again, we're looking at different confidence intervals, so we're going to start with 0.90. Evaluate, we get 423. Then we'll go up to 0.95. Evaluate, we get 601. And then we'll go up to 0.99. Evaluate, we get 1037. What happens to the sample size as the percentage of confidence increases? The sample size needed increases because in order to be more confident, we have to have a larger sample size. If we sampled everybody, we can be 100% confident. If we sampled only one person, it's such a small sample size, we're not confident that's going to end up a true answer or not. Right, so the more you sample, the more confident you can be. Okay, the values we find are the minimum. Right. So we will be looking at hypothesis test in the next chapter, which is going to build off of a lot of things we've learned in this chapter. I'll see you then. Bye.